Hello everyone, welcome to my YouTube channel The Learning Hub, and we are going through the series of lectures on machine learning. So we till now we have discussed about supervised learning techniques, in which we have done various classifiers, like we have done logistic regression as a classifier, we have done k nearest neighbor as a classifier, support vector machine as a classifier, and under regression we have done the linear regression. So in today's video we are going to discuss one of the again very much important topic, that is Bayes theorem. Bayes theorem, which is implementing Naive-Bayes classifier. We will be using Naive-Bayes classifier. So when we talk of this classifier, firstly, before discussing Naive-Bayes classifier, which is a supervised learning and it works on labeled data. Fine. So before proceeding further, we need to discuss about the various things that are required in Naive-Bayes that forms the basis for this. So here we will discuss about firstly about the Bayes theorem. So let's understand what is Bayes theorem. So basically when we talk of Bayes theorem, it works on the probability, prior probability and posterior probability category for classification. So we know that we have an equation in Bayes theorem. That equation is written something like this: B A of 3 P B of A into P of A divided by P of 3 P of B. Now let's discuss what does it mean. So here it means that the probability of occurrence of A with respect to event B. So what is it known as? Probability of occurrence of event A with respect to event B. Fine. And here it says probability of occurrence of B with respect to event A, and P of A is simply probability of A, and this is probability of B. So these terminologies have some very important meanings to this. So this PA of B is basically known as posterior probability. This is posterior probability, means the probability that we are going to calculate. And in this PB of A is nothing else. This is likelihood of happening of something. This P of B of A says likelihood of happening of something, that is the probability of occurrence of B when A has already occurred. What is the likelihood of this category? So this is a given factor. And here this P of A is the prior probability that is known, that is we already have some information. So when we talk of probability, we say we have some information and based on that we are proceeding further. So this P of A is the prior probability. And now what does is B? P of B means this is a probability of occurrence of B which is known as marginal probability. So in this case we are having four type of basically probabilities. So the thing, this value that we are going to calculate, that is probability of occurrence of A with respect to event B, is known as posterior probability that we calculate, or that Bayes theorem calculates. And here this is about that is likelihood of something, that says probability of B with respect to event A and in multiplied by probability of A, that is a prior probability of occurrence of A, and P of B is the marginal probability. So this is what we have in the Bayes theorem. Now let's see how we derive this Bayes theorem. Just let me open a new window. Okay, now let's see the derivation of this. So we will derive this equation. We are starting with P of A of B. It is equal to, we know what is the probability of occurrence of event A when B has already happened. We can write it as P of intersection of B divided by P of B. That is, so probability of occurrence of A with respect to event B means probability of occurrence of both the events divided by probability of B. This equation can further be written as P of A of B. So this B will go over here into P of B is equal to P of A intersection B. Let's call this as equation number 1. Now similarly, we will do for probability of occurrence of B of A. It is equal to, we know, probability of occurrence of both B and A together divided by P of A, which is equal to, which can be written as P of B of A. This will go here into P of A is equal to P of B intersection A. Let us call this as equation number 2. So this is the thing that we know. So now we have two equations, equation 1 and equation 2. So we can say solving equation 1 and equation number 2, but we will get over here, we will get a new derivation. We will get the, or you can say the formula for this. So we know this P of B intersection A and A intersection B can be written as either B intersection A or A intersection B. We can write anything from these two. So from this we conclude, that probability of A intersection B, it implies that P of A of B into P of B, which can also be on the other side P of B intersection A into P of A. So what we have done over here, we have used these two equations, this one and this one. Fine. So we have taken this side P of A of B and this over here. So when we solve this equation, this can be written as P of A of B, that is this thing, equal to, take this thing, it can also be written as P of just wait, sorry, here was here we were having P of A. So what we will get over here, P of B of A into P of A, that is complete this side, and this is over here, and this P of B will go over here. So we have got this equation. Fine. So this is our Bayes theorem. We know in mathematics we have this thing, we were having these values, we were knowing about these values. Fine. So we use these values, we have from this equation we have derived this equation, and from this one for probability V of A we have derived this equation. After that we solved the equation number 1 and equation number 2 on some commonality parameters, and what we have got over here as a solution, we have got this equation, that is the Bayes theorem. Now we will use this Bayes theorem for solving the problem. We will do the numerical problem of this. So as we have got this P of Y of A, let's write it like Y of X, which is equal to P of X oblique Y into P of Y, P of X. So here basically what is X over here, this X is a dependent feature vector with size n. So what is this x, or you can call say this x? This is a dependent feature vector of x. It means it is not a single value. It will consist of x1, x2, x3 as number of attributes. Like this can be age, name, contact number, email address, or whatever there is available in the dependent vector. This is taking those values. And when we talk of this y is nothing else. This is just a class variable. This is a class variable. So now when we write this equation, it can be written as y. As we know, this x is a vector of features, so we can write it like x1, x2, x3, so on up to xn, which is equal to this. Now putting these values over here, what we can write? We can write x1 of y, p of x2 oblique y, so on, p of xn oblique y. Fine. So from x1 up to xn we have values, and here into this y, p of y, it will go over here as it is. And what was there in the denominator? We were having p of x. No, so now let's put all these values over here. P of x1, p of x2, p of x3, so on up to p of xn. Fine. So here we have got this equation from there. So what will happen over here? Here we know that this denominator remains constant. This denominator remains constant, and hence it can be removed. We can remove this denominator and it is a constant value. So from this part, what we will get from this, we can rewrite it like this. This side is coming over here as it is, y of x1 comma x2 so on up to xn, which is proportionate to p of y, and this is basically the sum of product of p of x1y, p of x2y. We know that we can use pi, as the sigma used for summation and pi is used for representing product. So it is taking product of from 1 to n all the values, whatever is the value of x1, x2, x3, so and so on. So we are taking from I 1 to n, we are taking all the values, but it is taking xi of y. So this is basically taking the product of those values in this way. Now what is the next task that is to be done? So we find the probability of given set of input for all possible values of class variable y, and we pick up the output with maximum probability. What is to be done? We will find probability of given set of all the input variables for all possible values of class variables of y, and we pick up the output with maximum probability, which is the answer in this case. So now as we can pick the maximum probability, so how can we write it? We will write it like this: argument max, because we know all those x1 up to xn are arguments. So we can write argument max of what? Argument max of y of what? P of y into product of all the values I equal to 1 to n and p of xi y. So here from this equation we have derived this one. Fine. Now after this, finally we are left with the task of calculating py. Now we are left with the task of calculating py and p of xi oblique y, which will give us the resultant vector. When we calculate these values, it will give us the answer. So note, we can note over here that this p of I is class probability. Basically this pi is class probability, and this p of xi oblique y is basically conditional probability. Fine. So in this we have discussed about derivation of the formula for Bayes theorem. Earlier we discussed how what is the role of Bayes theorem and how the Bayes theorem's formula has been derived. After that we have proceeded with this, which is basically Naive-Bayes classifier, which is using which is used to calculate the posterior probability of this based on the prior probability and likelihood of factors. And from this we have seen that how this equation is being derived. Now as we have derived this equation, we have got the formula. Now we will solve the numerical in the next video. So stay tuned for this, and in the next video we will solve the numerical problem for Naive-Bayes using this formula. So thanks for watching the video, and if you have not subscribed my channel yet, then do subscribe it and click on the notification so that the example video, you will not miss the example video. So thanks for watching the video once again.